This is a Founding Media podcast, produced at Austin Community College District. Welcome back to Science in the Mall, y'all. I'm your co-host, Dan Dillard, and we're back with part 2 of Marcia and Mauricio's conversation about the cool science they've been doing since they left their internships at ACC's Bioscience Incubator. We kick off this episode with a conversation about Mauricio's work as a clinical laboratory scientist. He helps detect things like leukemia lymphoma in patients in a medical setting, which helps doctors make decisions about patient care. Marcia and Mauricio dive into the science of his day-to-day work and then discuss how the biosciences are an exciting frontier of innovation that gives them a chance to learn and grow every day. They get into the kind of mindset that is essential to be a successful scientist and close out with some invaluable advice for all of our listeners. Let's jump right in.
To do my line of work, which is basically screening patient samples for different markers that might indicate they might have a sort of leukemia or lymphoma, I use antibodies to try and get that sort of data. And I don't make these antibodies because that would be ridiculous. I have to buy them from someone. Someone has to make them, you know? So although Marcia's applications right now aren't for those kinds of things, she has more of a therapeutic approach from what I understand. It's still companies like hers that I would rely on and that so many hospitals need to rely on to be able to do all of these tests.
Well, and I assume that because you are testing clients or patients, and some of those patients have the deficit in their system, that Marcia's company may have a solution at some point that will make that happen, I guess, very loosely. Does that make sense?
Yeah.
Yeah. Well, and as far as when you look at genetic therapies right now, even with what Mauricio does, you've got early detection. I mean, like, it's right there. So it's not like even where it was 15 years ago, what we considered early detection you might be in your second stage.
Yeah. So what
wasn't found at first stage, but now with what Mauricio does, you can find it as it's just barely developing.
Because if the gene is broken or the gene is defective, the protein that it makes, which is all a gene is just like the code for a gene. I mean, for a protein, kind of like, there's a code behind the scene for blue Calibri 10-point font, right? It's just some code that tells it. So if the gene is messed up, then the protein's going to be messed up. And so the antibody won't bind to it. Or you can make an antibody that's really specific to the messed up version and detect whether it's there. There's like all these different ways to use that for detection, like she's saying.
So do genes change all the time? I thought the genetic code was like something that, I guess maybe I'm thinking DNA. DNA is something that's from the very beginning.
Oh, exactly. Okay. But it it replicates itself all the time. And every time it replicates itself, it runs a chance of making a mistake. And there's enough like proofreaders and stuff that are in the system. But, it's just like anything. If somebody's, picture that Lucille Ball one where she's like in the chocolate factory and she's cruising along every once in a while and she'll eat one and all of a sudden they're flying by her and she can't keep up. If your mutations and stuff are so much like from smoking or from sun exposure, it's just like break, and the cells are like, oh crap. They can't keep up. And so some of the mistakes get through and depending on where that mistake is, it can cause disease. It just depends on what that protein was and what its functions was and, what the mistake is. And
yeah, and when you look at aging, every time your DNA replicates, you have these little alleles at the bottom, and those get shorter and shorter each time.
Those are the telomeres, right?
Yes. Listen to Dan.
Yeah, and that's why as you age, your skin is not quite as good, or things start to go wrong because the DNA replication is just not as clean and swiftly cut as it was when you were 10 or 20 or 30, it gets a little lazy as it gets older. Let's put it that way.
I mean, honestly, I find it surprising that mutations aren't even more common than they are, or that malignancies developing from them aren't as common as they are. Because mutations happen all the time. They're random. And you can't be mad at our polymerases for having a mistake here and there. I think they're working pretty hard. They're certainly working harder than most of us.
Well, even if there is a mistake, it just depends on where it is, right? Like
exactly.
If it's not an important part, or go back to your 7th grade biology, every 3 nucleotides makes an amino acid. And so if it's in, and they overlap, like there's like 6 different ones that code for the same amino acid. And so if the mistake is somewhere in there that it can still make that amino acid, then the mistake just gets, it's invisible. It doesn't matter.
And even if it does make a mistake somewhere internally in the cell too, I mean, we've got all those cell checks, all those interleukins, everything is checking it every time. And we've got stops in the cells. So even if one cell does get a mutation in it, the cell cycle usually will stop it from replicating.
Right.
It's just finding out those cell stoppers.
And you have 2 copies of all these genes. You got one from your mom and one from your dad. And if one of them is cranking out and making this protein no problem, and the other one's making a stupid version of it, if there's enough of it to get the process done with the good one, then everything just carries on like normal, and you don't even know that you have a messed up copy somewhere.
So crazy, so interesting.
So that's what's sad of like how many things need to go wrong for a truly life-changing malignancy to develop, And although a lot of us in the molecular biology world kind of like think of like mutations, malignancies, and so forth on like the sequence aspect of it and the sequence synthesis aspect of it, in reality, a lot of disorders can happen like further downstream from that process. For example, the sequence can be created and the chromosome can start taking shape. And some leukemias, for example, can occur when in the cell division process, there's a translocation that happens between 2 chromosomes that isn't supposed to happen. So if the sequence is perfect, but in the cell division, you have 2 chromosomes that translocate on top of each other when they're not supposed to, that's going to have a huge impact, arguably a bigger one than you would have if you have a couple of base pairs that are wrong, And that's the way that scientists do genetic analysis to try and figure out what kind of leukemias some patients have. Not related to my line of work entirely, but yes, I think one of the gold standards for diagnosing, for example, chronic myelogenous leukemia is looking for a specific type of translocation.
Oh, you've gotten so big. I was like, oh my gosh, I'm so proud of you.
So how much of this did you know by the time you started biotech? Well, how much of this did you know by the time you finished biotech? How much of this did you know by the time you left ABI?
I mean, I think like it's a young person thing to overestimate your knowledge. And I think that's definitely one of the better aspects of higher education is that it usually humbles you and it exposes you to how little you actually know and how much you truly don't know. So I think when I started the biotech program, when I got into ABI, I actually felt really overconfident about like my knowledge of molecular biology and just biology in general. And the longer I stayed at ABI, the more I realized like, oh, I like know basically nothing, like just like such a ridiculously small amount of knowledge in there. And when I started my program after ABI, it like just continued that trend, So I'd say that if you think you truly know it all in any specific field in bioscience, it just means that you haven't really been exposed to that much,
Or you're a jerk.
It's either that or you're just not hungry enough. Because the bioscience has changed. It seems like every freaking day there is some new thing coming out, some new concept, some new thought, it literally just changes. And I was very fortunate that I did not have any manufacturing experience. I didn't have clean room experience. And X-Biotech took me on, but I am thankful that I go to work every day and I still learn something new. I'm never going to say I know it all. That I'm at the top of my field. Other than that sounds really boring because you wouldn't be learning every day. There's got to be that what am I going to learn today? What's going to spark some new thought in me? Because if I'm learning something new, then that changes your thought process of other stuff. It's I'm rambling. I'm sorry.
I would argue that that's not necessary, and that you could walk in there and be the drone that does the crap that goes home and whatever.
That wouldn't be for me.
No, I'm saying right, and I'm going to argue that the reason that you are, have a more lofty title and are actually moving up and doing that is because of what you just said, right? It's because of your hunger for knowledge and the fact that you're not a jerk that thinks you know everything and that you're willing to try things that are new.
I work around some great, there's PhDs, there's people that have been years in this, and I listen to them. I want to hear what they have to say. I want to hear what they have. And I've also got people that just started that come up with ideas. And they could be fabulous ideas, but if nobody listens to them, then they're never going to get very far. So I try to learn from anybody I can and listen to ideas, because that's what makes it fun.
We love to see it. And then honestly, like the way that you put it all into words, like to me, it just sounds like genuine passion, for like your work, for your field. And it's so important. And would you say that maybe that's what drives it, your passion for this field, just the fact that there's so much to learn constantly and there's no really end in sight for that?
I think that would put it into words perfectly, because it does change every day. I can remember my mom, she's an engineer, and she would they would do like these refresher courses, because although she was an engineer, she also did computers. And so they'd have to do these refresher courses. And she tended to lean more towards the computer end of it because it was changing. Okay, so she went to school with the little boxes of cards that you had to feed in and all this stuff. So as the computer industry changed, she liked that it was growing and moving, and she tended to she stayed more with that. And I think growing up, seeing that made me want to stay that way also, to be constantly learning and watching it change.
What about your passion, Mauricio? I love that, and not take away from that, but I'm just also curious, is there any of that that reflects on you, or do you have a different, does something else drive you?
Yeah, honestly, I'm trying myself to figure it out, honestly. So I'm prodding at Marcia's brains because, again, she was my first exposure to a real lab scientist, working in the lab. So she's a bit of a role model to me, at least at the beginning of my career. And then to see her again now, as I face the struggles of my field, as I have the harder days of my professional life, I think I just want to see for myself what does the role model that I looked up at the beginning, what are they driven by, and I think I do share at least a little bit of similarity in that sense. If I had gone into a different profession, although you can make the argument that the learning never stops anywhere, I think that for biosciences it's just so much bigger as far as that truth goes. And I think that's probably one of the bigger ones that drive me. But I can't give a 100% whole answer because I'm still trying to figure it out, to be completely frank.
Passion, and I call BS.
It's coming from somewhere.
Of course, the passion is there, but where it comes from, what it's fed by, I'm investigating that a little bit more.
Well, you mentioned before where you've had this passion since grade school into science. Is that correct? So I was trying to get to and that's great that you've carried it on, and maybe it's not the same learning every day, but it's something way back when turned on in you, and I'm going to go down this field, which I think is really cool, and you can elaborate more on that if you want.
Yeah, the more that you look at your life in retrospective, the more that it just feels whimsical and random. Because I think when I was a little kid, at one point I saw a video of bacteria dividing, and I think that was probably the nail in the coffin of that's what I want to do and look at and see.
I want to be a bacteria when I grow up.
Yeah. So you have to be grateful, when like just tiny, like seem almost borderline insignificant moments just like drive the rest of your passions in life and like what you end up devoting yourself to. Like, it's kind of beautiful. What can I say? But yeah, like I think that it's just so important to get as many of these resources to people like as early as possible, just so that they know what they're getting into, so that they know like where they can go. I wish I had heard of my field that I ended up committing myself to like way earlier in life. But yeah, I think like just like the loose passion of science like will lead you to where it needs to lead you regardless.
That's what I love about this conversation is that if you think about the audience that is going to join us and listening to this, they've got the same questions in their mind, which is like, I like this, I just don't know where I'm going, and I'm not sure. And there's like all these unanswered questions, and I think all of us throughout life are always changing and growing. But what I love about the conversation is it allows to be like, we don't all have the answers. It just kind of develops along the way, and things happen, and they're really cool things that happen, and just kind of, it's okay to just keep moving forward.
And I bet you if we came back together, 10 years from now, it'd be, oh, that was my past life. Now I'm doing it because it is changing, and you say yes to what's presented in front of you. Like you said yes to getting into college, and you said yes to trying, an internship you didn't know about, and you said yes to, putting on a bunny suit and doing whatever. Like, as long as you're saying yes, 10 years from now, you're probably gonna be like, oh yeah, I did that for a while, but now I've already like moved way past that.
My granddaughter came and visited me at work, and we still had some people were inside the clean room, and I was able to lift her up and let her see through the window. And I said, "Now that's what Grandma looks like when I'm actually in there." And she just gave me the weirdest look. She's like, "Why?"
How old is she?
Want to be clean. She's 5.
Oh.
And she was like, "Why?" And I was like, "Well, we want to keep everything clean in there." And she's like, "Well, just wash your hands, Grandma." And then
it's kept me COVID free, so like, why don't you just do that?
But again, I thought I was showing her something. Look at this. This is what I get to wear, and this is where I work. And all she could do was just wash her hands.
Can we make the? I want to make the cover art for this episode, Marcia in her outfit.
Oh, that would be fun.
Yes, please. Oh my God.
Well, do you want it in our full, because we have an actually full bunny suit that we wear when we cell bank that has the hood, the full thing. You basically just see the eyeballs. And then when we do our everyday work, it's the booties and the bib and the mask and the hairnet and the gloves and the sleeves.
I think votes for everything.
Yeah.
So I have my casual and I have my dress up. Which one would you like?
Dress up.
But was that hard to get used to? Because I think that would be a deterrent for me. I'd be like, ooh, I don't know about that.
I wasn't sure at first, but I really wanted to get my foot in the door. I felt like I could do the job. And if it meant that I had to change into this every day to do my job, then I was like, I'll do it. I'll try it. And it actually now it's part of the
routine.
You don't even think about it.
It's part of who I am now, because now it's part of my routine. And we actually joke about it sometimes because Upstream does spend so much time inside the clean room. But I told him, I said, we should run an experiment. We should wear the same clothes every day for a week and see if anybody even notices, because nobody ever really sees us outside the clean room. Maybe like 5-10 minutes in the morning, a little bit of lunch, and then we're back in. So I said, I bet you we could wear the same clothes every day. Nobody would know the difference because they're used to seeing us inside in our suits.
And it's true that people that go to schools that have uniforms, and I remember in high school, I went to public high school, we wore whatever we wanted. And people that went to these ones with uniforms, you go, oh man, that sucks for them. And they were like, this is so awesome. I don't have to think about what I wear today. Nobody pays attention. Nobody's like one-upping each other on their fashion. It's like so much easier.
Yeah, well, this was like they said. Albert Einstein wore the same outfit every day. He had different changes of it, but it was the same color shirt, same color jacket, same color pants, same shoes, and he just wore the same outfit every day. So he didn't have to clutter his mind with what to wear.
Keep your mind clean for other things, for sure, or open for other things, for sure.
But scientists also just have zero sense of fashion, so that could have something to do with it.
I wear my science shirt. I'm very lucky because they have a very manufacturing. They do give us a little leeway with our dress code there, mainly because we have to change in and out of it all day. So I wear jeans, some very nice, comfy tennis shoes, and a science shirt. That's what I wear every day. I don't have to decide. I just pick out what shirt, and then I pick out a shirt, my pants, and then I'm off.
Love it.
So.
Last thoughts.
And I've seen Mauricio in his scrubs, and he's
we need to do both. We need to make
day.
sure you both have the outfits on for sure. Last thoughts. I'm just curious, is there anything else other than, just follow your passion and know that it'll develop into its own thing? Is there anything else that we should share?
I would like to reiterate what Nancy said. Say yes. Don't be afraid.
Yeah.
When I would take my cell culture class, I thought, you know what? I want to see. I liked it. I mean, it was very interesting to me. It was a challenge. It was probably one of my more challenging classes, and I thought, I want to do this. But then I looked in like the, Indeed, and for anything that said cell culture, and there was like one position. And I was like, there's 30 people in just this class. There's one position out there. And I thought, no, I'm still going to do it. I'm going to do whatever I can. I am going to work in cell culture. And now here I am. But it did take a lot of, it wasn't like I went, oh my God, and I did it. And then it just happened. I did. I said a lot of yeses, and I took a lot of chances, because it would have been safer not to go so specific and it's like just cell culture, because there's so much you can do in biosciences.
Yeah.
And I was very secular of what I wanted to do, and that was a risk, but I'm glad that it paid off. But don't be afraid. If you think, I want to try this and I want to do this, but you only see one job out there, just be the best that you can be, and you will get that one job.
My side of that coin would be if you're in a point of your career that like you don't really know where you're gonna end up, but you're given the opportunity to have like a learning experience through a job. Me, for example, in the incubator, take everything as seriously as you can and deep dive into as many things as possible, because you never know where a couple of years down the road, one of those things might be like the bread and butter of what you end up doing, even if you don't see it at the time, the way that this field is, the many different routes you can take, you really never know how full circle it can go, as it went for me, for example,
Yeah, I don't know if you know that story, Marcia, but flow cytometer is his thing. He's like, came in one day, he said, oh my God, Nancy, I used to struggle on that stupid thing and none of us knew how it worked. But I get it now, and I can come back and show you guys, because it's not
literally my job now.
And it's not something that we ever, we did a ton of cell culture, and we did, the FPLC comes up a lot because a lot of people played on that and stuff. Yeah. And flow cytometry was not one of them. But Mauricio did take it as his thing, and it wasn't his main thing. He did ELISAs, and he did research and development, and he did cell culture. He did, like he's saying, he jumped in as many things. Yeah. And the flow cytometry would not have been what any of us would have guessed that he'd be like nailing it, right? Because none of us even got it. We're like, why are you doing that? I don't know, just turn it off. Just turn it off. Yeah.
It's me like able to figure out like what QC meant and how to do QC on the flow cytometer that let me, out of any applicants that applied for my position, get my job.
Wow.
I had classmates that applied for my position that had the same amount of educational credentials that I did. And what ended up giving me the edge was that experience in the incubator. So yeah, you can never take, if you're giving an opportunity, like squeeze it to its limit,
Squeeze it like a lime.
Yes. No.
Awesome.
My psyche is just lines.
Love it. All right. Well,
I definitely agree with that too.
I think that's both of those are really great points of view and really great advice. I think that I really enjoyed the conversation. I know there's so much more we can chat about, and we need to just commit to just get you guys back on the show soon.
Yeah, I would love to.
And in 10
Thank you so much for having me.
And in 10 years. Thanks, Mauricio and Marcia, for joining us on Science in the Mall, y'all. It's inspiring to hear your unique journeys. While becoming a doctor or a nurse is a great career path, it's exciting to consider all the other behind-the-scenes jobs in bioscience that can help others in profound ways, like the work that Marcia and Mauricio do in diagnostics and therapeutics. If you know someone who's interested in a career in bioscience, share this episode with them. And thank you so much for listening to Science in the Mall, y'all. Tune in to our next episode to learn more about Marcia's work and to get some insight into what bioscience companies look for when they're hiring. This is a Founding Media podcast in partnership with Austin Community College's Bioscience Incubator, which is the region's only wet lab space for Austin's growing bioscience industry. If you like this episode, like and subscribe.